Okay, so as in the last video, we have discussed about quantum numbers, the four quantum numbers. Initially, we discussed about principal quantum number, then azimuthal quantum number, afterwards magnetic quantum number, and then in the end, we discussed about the spin quantum number. Initially, principal quantum number were denoted with letter n, and they gave us information about the size, means how much big the atom would be in this form of shells, alright. And we know that the shells are represented with letters K, L, M, N, and so on, alright. Then we have discussed about azimuthal quantum number. Azimuthal quantum number were represented by letter L, and they gave us information about the shape, which means they told us about the subshells, right? They told us about the S, P, D, F. S means spherical, P means dumbbell, D means double dumbbell, and F means 8 folds, right? Then we discussed about magnetic quantum number, which were represented with letter M, and they gave us information about the orientations, which means they tell us about the orbitals, right? If there would be S, there would be one orbital. If there would be P, there would be three orbitals. If there would be D, there would be 5 orbitals, and if there would be F, there would be 7 orbitals. Alright, we're gonna check today how we have orbitals, like if we have 1 in S, why there are 3 in P, then why there are 5 in D, then why there are 7 in F. We will discuss each and everything today. So then in the end we discuss about spin quantum number, and spin quantum number were presented with letter S, and they basically told us about the spinning of an electron. Either that electron would be spinning clockwise or it would be spinning anti-clockwise, right? So we just saw a basic introduction, or we just discussed about the basic introduction. Today we're gonna see why there are 1 orbital in S, there are 3 orbitals in P, there are 5 orbitals in D, and why are there 7 orbitals in F, right? Why there is 2 type of direction of the electrons, right? Why an electron revolves clockwise and why then another electron revolves anti-clockwise. Today we're going to discuss each and everything in very detail, and then we in the next video maybe we're going to discuss about the Pauli's exclusion principle as well. He has played a very big role in this. I am going to tell you why and what his principle tell us about. All right, initially for discussing each and everything in very detail, I need to write here the quantum numbers. So initially principal quantum number, principal quantum number, which is of course denoted with letter N. That I should make with white and highlight with yellow, alright. Then we discussed, wait, okay, I'm sorry, principal quantum number, alright. Then we discuss about azimuthal, quantum number, which is of course represented with letter L. Then we discussed about magnetic quantum number, which tell us basically, I'm going to tell you why does it tell us about the direction of the electron or direction of the orbitals, right? Magnetic quantum number. which is of course denoted with letter M, and in the end spin quantum number. Quantum number, which is denoted with letter S. Alright, so I have wrote here 4 basic quantum numbers: principal quantum number, azimuthal quantum number, magnetic quantum number, and spin quantum number. Alright, I have initially told you that principal quantum number basically tell us about the size of the atom, and we know that there are shells in it, which means basically it gave us information about the shells. It gave us information about the size. The more shells would be there in an atom, the more size it would gonna possess, right? So size, or principal quantum numbers are basically tell us about the shells, and shells are represented with K, L, M, N, right? So initially we are discussing about K shell, right? Shell K. Now azimuthal quantum number would gonna be what? Its value would gonna be started with 0, is less than and greater than m, and m is less than and greater than n minus 1, which means what would be the value of n? This m would be less than only 1 less than this n, right? Here means n is 1. K represents what? K represents 1, right? K represents 1. So now what would be the value of azimuthal quantum number here? It would be 0, because n minus 1, n is 1, and 1 minus 1 is 0, and our magnetic quantum number starts with 0. So here the value would be 0, right? Its value would be 0. Its value is 0. Alright, then what's the formula for the azimuthal quantum number is done now. Now we need to check the formula for the magnetic quantum number. The formula for magnetic quantum number is minus L is less than and greater than M, and M is less than and equal to plus L, right? Minus L is less than equal to M, M is less than equal to plus L, which means whatever would be the value of M, we're gonna take that and minus. From that minus we need to take the positive value of it. Initially here we have 0, so we're gonna take here the 0. Alright, we're gonna take here the 0. Alright, now spin quantum number. Alright, now this 0 basically here azimuthal quantum number basically tell us about the subshells. Alright, and subshell here basically would be S. Alright, so it would be S here, S, which means here the size would be spherical. If there would be 0 azimuthal quantum number, if there would be 0 magnetic quantum number, there would be S spherical shape. Alright, now here we have 0, which tell us about the orientations. So there would be only one orientation because there is value 0. And if there is value 0, we are gonna take, right, only 2 electrons, because one orbital will gonna have 2 electrons in it. So we are gonna have 2 electrons in it. Alright, and their movement would be, one electron would be clockwise, one would be anti-clockwise, because if these two will gonna revolve anti-clockwise, then there would be repulsion in it, right? We don't want to make it to be repulsed, right? We need to make it stable. That's why we have made clockwise and anti-clockwise, so that they cannot repel. Now we are talking about shell number L. Since we are done with shell number K, so now shell number L. Alright, and we know that in L we have second shell. Alright, and m value would be greater than and equal to 0 and would be less than and equal to n minus 1. Alright, which means here we're gonna have 1 0, and n minus 1. So n is 2 minus 1 means 1, which means here 1 is included as well, right? So 0 and 1, which means here we will have S and 1 means P. So here we have two subshells, S and P. Alright, in S, now see what value would be in the S here. We know that there would be only 0. Alright, and there would be only one orbital. Now see, minus L is less than equal to m, and m is less than equal to plus L. Alright, so now here we have basically, alright, so our L is basically 1, so we need to take minus 1 since our m starts with minus 1. Minus 1, 0, and then basically we have plus 1. Alright, which means P will gonna have 3 orbitals in it. So 1, 2, 3. Alright, 3 orbitals in P. Now let's make the spinning of it. Initially in S we have again only one orbital, and there we have only 2 electrons in it, and they two revolve anti-clockwise. Here we have 3 orbitals since this is P, and here we will gonna have how many electrons? We will gonna have here 6 electrons. 1, 2, 3, 4, 5, 6. I am gonna tell you about the filling of the electron as well when we will gonna discuss each and everything in the electronic configuration. When I am gonna teach electronic configuration, I am gonna tell you guys or teach you guys how do we, fill the electrons in the shell, alright, or in the orbitals. We'll discuss each and everything in very detail. Alright, so we have discussed shell number L. Now we want to discuss about shell KLM, and M is basically shell number 3, right? Here we will gonna have, because we need to start with 0, so 0, right? 0, 1, here 2 would be included as well since 3 minus 1 is 2, so 0, 1, 2, right? Which means S, P, D. Now here we are gonna have D subshell as well. Alright, for S we have already calculated, there is only 1, 0. Alright, then in P we have minus 1, 0, 1. Alright, now we need to check for the D. Now we need to check for the D. Alright, now see, the value of D is 2, so we need to take minus 2, right? Minus 1, 0, 1 and plus 2. Alright, as using per formula. Alright, so in S there would be only one orbital, in P there would be 3 orbitals, in D there would be 5 orbitals. Now have you guys seen why do we have 5 orbitals in D and why do we have 3 orbitals in P? As like this, we're gonna see why do we have 7 orbitals in F as well. Alright, so here we have only one orbital, here there would be 2 electrons, here we're gonna have 3 orbitals, so 6 electrons, here we're gonna have 5 orbitals, right? Because this is D, so we're gonna have 10 electrons here. Now let's make the spinning of the electron. 2, 2, 2, 2, right? 2 electrons in each orbital, right? Now let's discuss the last one, which is shell number n. KLM, now n, which is of course shell number 4. Now I'll make very quickly. Here we're gonna have 0, 1, 2, less than 4, so there will be 3, all right. So here we are gonna have S, P, D, F. In S there are 0, P +1, 0, -1, D -2, -1, 0, 1, 2, and in F we have -3, -2, -1, 0, 1, 2, and 3. Means 1, 2, 3, 4, 5, 6, 7. Now have you guys seen why do we have 7 in D? So 1 orbital, 3 orbital, 1, 2, 3, 4, 5 orbitals in D, and 7 orbitals in F. 3, 4, 5, 6, 7, 7. Now let's make the electrons spinning in this. Here we have only 1, here we have 3, here we have 5, and here we have 7. 6, 7. Right? 2 electrons, 2 electrons, 2 electrons. We're gonna see why do we use Hund's rule. I'm gonna tell you when I'll teach you about the electronic configuration. Initially, in yesterday's video, we're gonna discuss about the Pauli's exclusion principle. That would be the last subtopic of the quantum numbers. Then in next video, we're gonna discuss about the electronic configuration and the rules of filling the electrons. Alright, we're gonna see Affa principle, Hund's rule, and in yesterday's video we're gonna discuss Pauli's exclusion principle. So this was all for today.